Hello, this is Mr. Serrano with the EOC 2024. I'm going to try to go in order. However, will be some questions that I will skip because they will take too long. So I will create another video at the end with the longer questions. But let's start with number one. We have a formula, and this is literal equations. The formula is A equals to 9E over N. And the question is asking us to solve for E. That means I need to isolate the letter E. So what do? We need to start doing the opposite operations. Right now, E is being divided by N. So I'm going to multiply times N on the right of the equation as well as on the left. What is that going to leave me? That's going to give me AN, to be alphabetically in order, is equal to the n's cancel 9e. Okay, now the e is being multiplied by 9. So my next step is going to be to divide both sides by 9. Okay, so let's do that. Let's do that. When the 9's cancel into a 1, I'm going to have that e is equal to an over 9. So e is equal to a times n over 9. I am going to click then on B, choice B, if I can click it. If not, you guys click it. Let me see if I can do this. So what I'm going to do is I'm going to pause the video, or ask you to pause your video as I delete what I wrote. And from now on, like when I say pause, you can go back, you can rewind and pause it as you need to. But so far the answer is B right there. So pause the video as I erase my annotations. AN over 9 was my answer, and I'm going to click next. Okay, number 2. This is now a function that is 7x plus 4y is equal to 14, and I need to graph it. So one way to graph it when it is in standard form is we're gonna set x equal to 0 to find the y-intercept, and then also y is equal to 0 to find the x-intercept. So y is 0. So we need to do this 7x plus 4y twice is equal to 14. We need to do it once, and we need to do it twice. So maybe on the left. So let me start with x equals 0. When x is 0, 7 times 0 is 0, that is gone. So now divide by 4, and y is equal to 14 over 4. That's 7 over 2, that's 3.5. In case, well, you have a calculator function here, but it's 3.5. So when x is 0, y is 3.5. I can already eliminate B and D, sorry. Okay, so here, now we're gonna set y equal to 0, so 4 times 0 is 0. So 7x is equal to 14. Divide both sides by 7, and x is equal to 2. So when y is 0, x is 2. And so I need to look for a graph that has 0, 2, and 0, 3, 5. That looks to be A. And A will be my answer. Okay, so that's what you do. You set each variable equal to 0, solve, and then you get the intercepts, since you already had the form in standard, not in standard form. So the pause, so you can, I can erase and you can continue. I'm choosing A, and I'm moving on. All right, inequality now for x plus 5y is greater than or equal to 10. Same thing, it's in standard form. So let me do what I did for the previous problem. Let me say 4x plus 5y is greater than or equal to 10 when x is 0. So that's going to be gone because 4 times 0. And so dividing by 5, y is greater than or equal to 2. So 0, 2. I bet you they all have 0, 2 now. Of course they do. All right, so let's find the x-intercept. So I'm going to say y equal to 0. So for x plus 5 times 0, because y is 0 now, greater or equal to 10. That's gone. So 4x and 10 divided by 4. 10 over 4 is 5 over 2, so x is 2.5 when y is 0. So when y is 0, x is 2.5. So 2.5 for x is right here or right here. So now how do I know which way to shade? This is telling me that both x and y are greater than, are numbers that are greater than 2, numbers that are greater than 2.5. I can always check with the 0, 0 to see if it goes here. So if that were the case, 4 times 0, which is the x from this point 0, 0, plus 5 times y, which from the point 0, 0 is 0, that would be greater than or at least 10. And so this is 0 plus another 0 is 0 is not greater than 10. So I know that I cannot choose D. The other ones have the wrong 2.5 because it's positive. The answer has to be C, but I was saying is that because it says greater than, from the get-go right here, it says greater than, I know that I need to shade above the line. And because it has the equal, greater than or equal to, I know it has to be a solid line, not a dotted line. But in this case, all lines are solid, so that wasn't the issue. The issue was which way to shade. Greater than, you shade above the line. Less than, you shade under. So that's why this one didn't work. This was not true. 0 is not greater than or equal to 10. Okay, pause your video as I erase, as I move on. My answer was C. Let me see if I can do that. C is the answer above. Let me go to the next question. Question 4, another inequality. Let me make it a little bit bigger so you can see. So when it says or, it's going to be an inequality that we're going to graph to the lined arrowheads. So let's do it. Or means there are two, so let's do it one at a time. 2x minus 1. So in order to solve for x, I need to add 1. So that means that 2x is less than or equal to 4. Dividing by 2, and x is less than or equal to 2. The other inequality, the second half of it, is 1/2 of x plus 4 is greater than 7. I'm going to go ahead and subtract 4 to leave the x term. So let me take away 4 from both sides of the inequality, and I get that 1/2 of x, that 0, is greater than 7 minus 4, 3. Okay. To do the opposite of dividing by 2, which is a half, I need to multiply both sides by 2. So I need to multiply this side by 2. That will cancel into a 1, and then 3 times 2. So x is greater than 6. Now notice that this The numbers greater than 6 have to be open and greater is going to the right. And in this case, x less than or equal to -2 is a closed dot over the 2 because is equal to, so 2 is part of the solution, and the numbers that are less than 2 are to the left of 2. So I'm looking for 2 closed and 6 open and towards each end. So like this, 2 closed. You can see that the 6 is open here and it goes towards the end. And so my answer has to be A. Let me check for other answers. These two are in the middle, so that would be an OR compound inequality. And this one has the wrong open and close points based on the fact that this one does not have the underlining, which is the equal sign. So the answer is definitely A. Pause your video. All right, another inequality for number 5, or set of inequalities, we'll see. So let's go ahead and do that. Okay, it's only one inequality, it seems. So we have -3x plus 7 is greater than or equal to -1x. I'm gonna put the 1 minus 5. Okay, so this is an inequality with x's on the left and on the right of the inequality. So I need to get rid of the x's. Usually I like it on the right to take them away from the right. So I'm going to add 1x on the right. So that's a 0. And I'm going to add 1x there to the -3x. If I clean things up and go down to the next line, that was like bullet number 1, bullet number 2. After adding 1x, I get -3 and +1 is -2x plus 7 is greater than or equal to -5. Okay, to leave the -2x's alone, I need to take care of the +7 by subtracting 7 from both sides. Great. Remember that when you subtract from a negative, you're actually adding because you have a -5 and then another -7. So it's like double the expense, double the negative. -2x, then that's 0. Greater than or equal to -12. If you remember the rules, which is okay with me, the same signs you have to add, so and keep the sign. So 7 plus 5 is 12, and you keep it negative. Now we need to divide by -2. Don't forget to flip it real good. Flip it, flip it, flip it, because we're dividing by a negative in order to solve for x. So now my symbol has to be less than or equal to. Important. All right. Remember those rules. So I'm reminding you, in other words. So I have x is less than or equal to -12 divided by -2. That's going to give me a +6. And so x such that x is less than or equal to +6, because I'm dividing a -12 times a -2. So my answer seems to be A. I don't see any other one. Let me do a quick double check of what is going on. Did I copy the problem right? Okay, did I add a +1x? That gives me -2x. Take away 7 and I get -12 divided by -2. Flip the sign and it's +6. So yes, it is A. Pause your video. Okay, sum is combining like terms. And it's not combining unlike terms. And like means exactly the same to the exponent. So I can only add x to the third power with x to the third powers. I cannot add x's with x to the third powers because they're different exponents. They're not like terms. I know this kind of like, but we don't mean in mathematics kind of like. We mean exactly the same term after the coefficient. So I'm going to combine the 2x cubed with the 3x cubed, and that's going to give me 5x cubed. I cannot do the combination with the x because the x has an exponent 1. So I now need to simply separately add the 4x and the 5x, and that gives me positive 9x. Do I have that in my choices? Yes. Choice C is the right answer. Let's double check. We're correct. Pause your video as I clear and move on to the next question. This one was 5 and 9. So answer C, continuing. 7 is leaving for the long questions period. It would take too long to solve the system, and we need to be quick, save time, and if we have time for these questions, then we do them at the end, which is what I'm gonna do with my video, so leave for later. Okay, so I'm going to choose any answer here in order to move on, right? No saying that that was the answer. Okay, so we need to understand something here with the exponents and the radicals, right? So if I have a number 2 and is raised to a fraction, the exponent is a fraction, sorry, m over n, that means that I can rewrite it as a radical with an index n, so the denominator goes in there as the index, and the 2 to the m stay inside. So it's now 2 to the m. The denominator, the division is the index of the radical, because remember, taking the square root is like is going to a smaller number, which is like division. So the square root of 9 is 3. It's kind of like dividing 9 into a number that is the same. So 3 times 3 is 9. So having said that, we need to know a few invisible numbers that are here. When you see a number and you don't see an exponent, the invisible exponent is always 1. So this is 3 to the first power, unless otherwise indicated. If it was 3 to the 0, you would have to have a 0. 3 to the 2, you would have to have a 2. And the same thing with the index for the radicals. When you have a 3 there, that means that's the cube root. The cube root of 64, by the way, is 4. Fun fact. So when it is empty, we have to assume a 2. So we know that this number goes as the denominator. So it's 3 to the 1 in this case is going to be 3 to the 1. And the index here is the denominator of the fraction. My invisible index is 2, so this is 3 to the 1 over 2. And that's no other way to explain it in the short amount of time we have. So 3 to the half is the square root of 3. Anything to the half is the square root of anything. So n to the 1/2 is the same as the square root of n. Pause your video. Okay, so when we see a line like this, the closer the points are to the line, the stronger it is. So closer to the line means stronger. So wherever it says weak, we can cancel. All right, now if the line is rising, if you see that when the x values are going higher, say from 1 to 15, 15 is higher than 1, and this number's 4, and when we go to 15, this is going to 18. So when they both are increasing, right? So this point indicates 15, 18, more or less. And a previous point such as this, let's see if we can find a close point. Let's say this was close to 2 and 6. We can see that it went from 2 and 6 to 15 and 18. So that's an increase in x and an increase in y. So this is a positive, strong correlation. So pause your video. Okay, in this equation, we have something that, if you notice, is divisible by 3. So I'm going to do that. Divide everything by 3 to make things a little bit easier. All right, so we have dividing by 3, divide by 3, divide everything by 3. And you can use the calculator function on your test, but because I have to toggle between writing, let me see if I can do it. Okay. So let me see if I can divide. The calculator is gonna show up here. So as I write, 3 divided by 3 is 1. Remember, it cancels into a 1, no, that's 0. 21 divided by 3 is 7 equals, and now I do 222 divided by 3, 74, already there. Okay, so now I need to set this equation to 0. Sorry, I need to solve for x, so I need to get rid of the negative 7. So x squared, I'm going to add 7 to both sides. It doesn't matter where I write the 7. I'm adding 7 to both sides. This is 0. And this is 81. Okay. Now now is when I set it equal to 0. So I'm going to subtract 81 from both sides. And this is going to be x squared minus 81 is equal to 0. Why do I do that? Because a quadratic equation will have usually 2 solutions. Sometimes it has 1, sometimes it has no real solutions, but the exponent 2 tells me I may have 2 answers. They're asking for 1 of the exact solutions. This is difference of squares, where it tells you that x squared minus y squared is the same as x plus y times x minus y. So we take the square root of each number or letter, and we multiply the sum times the difference. So in this case, the square root of x squared is x. So this is going to be x plus times x minus. And the square root of 81 is 9. If not, we can clear this in the calculator and do 81 square root. Let me see if it works this way. No, I needed to press that before. 81. It tells me that is 9. So I know to put a 9 here and a negative 9 is equal to 0. In order to solve each of these parentheses to 0, in this case, I would need to subtract 9, and in the other one, add 9. So in this case, x is negative 9, because negative 9 plus 9 is 0. And in this case, x is 9. You can easily see if I put a 9 here, 9 minus 9 is 0, so x is equal to 9. So you can choose either one for your answer. Let me go to the piece here. So let's say you just want to put 9, or you save time by taking the square root of 81, it's all you want. You can do that. But I wanted to show you the whole thing about the difference of squares, the calculator, and everything else. So pause your video. And as you pause your video, I am clearing my things. I am answering 9 and I'm saying next. Okay, great. This is an awesome question because we have an exponential function. What does that mean? It means that I have an exponent x right here for all my choices. All right. I also see that I have 2 easy points. This point is 0 for x and 0.2 for y. And then this other point is 1 for x, and 0.1 for y. So if I take this and I put 0 as x, my exponent is going to be 0. So let me do that. Let me erase these things, and I'm going to pretend that my exponent is 0, right? To get this value here, to get the value of y when x is 0. What happens when x is 0? You also have to remember that anything raised to the power of 0 is 1. Okay, it's not 0. So that parenthesis to the 0 is 1, and everything outside the parenthesis stays outside the parentheses. So that's 0.2 times 1. This is 0.2 times the parenthesis to the 0, which is 1. And then this is 0.1. But I know that 0.2 times 1 is 0.2. And so when x is 0, I need y to be 0.2. So I'm going to eliminate C and D already. Okay, to find out if it's A or B, I'm going to use 1 for x to see if I get 0.1 in y in those equations. So for A, I get 0.2 times 1 minus 0.1 to the power of 1. And we know that everything to the power of 1 is the same. So that 5 to the power of 1 is the same as 5. So, great. So the other one says 0.2, 1 minus a half to the power of 1. So here is 0.2. 1 minus 0.1 is 0.9 times 0.9. I know that that's not going to give me 9 times 2 is 18. I know that that's not going to give me 0.1. But this one, 1 minus a half is a half. So it's 0.2. The one exponent, again, we don't need it because it's the same as 1 minus a half. So 0.2 times a half. What is half of 2 is 1. What is half of 0.2 is 0.1. So when x is 1, y is 0.1. And so the answer checks for choice B. Choice B is the only one that gives me those 2 points that I found. There are more points, but we don't need them. So pause your video as I clear all my drawings, choose my right answer, and keep moving on. All right, this equation is called, some people call it FOIL. I don't like to call it FOIL. I like to call it double distribution. If you prefer FOIL, it's the same thing. The point being is that I need to multiply 7x throughout the second parentheses, and then I need to multiply the 2 throughout this, distributed throughout the second parenthesis in multiplication. So I'm gonna write it out, spell it out, because some teachers don't do that. I don't have to do that depending on how much the students already know this method, but I'm going to write it out as multiplication. So I'm going to start with 7k times 5k. Then it's 7 times the negative 9. So then I do 7 times negative 9. All right. Then I'm going to do a positive 2 times 5k. And then a positive 2 times a negative 9. All right, so this will give me 35, k to the second power, because 7 times 5 is 35. 7 times 5 times k is 35 to the second power, minus, because there's a negative, 9 times 7 is 63k. I think I forgot the k, let me see, on the 7. We can have it still. I still caught up with myself. 2 times 5 is 10k. And 9 times 2, 9 negative is negative 18, 9 times 2 positive. Negative and positive is negative. Minus 18. I noticed that the minus 18 doesn't help me. But if I combine these two k's that are like terms, a negative 63 and a positive 10 gives me a negative 53k. So my answer is 35k squared minus 53k minus 18. That's choice C. I would double check it, but I have done this a few times, so I know is the right answer. This time I didn't make too many mistakes. So pause as I clear all my drawings, choose the right answer, and move on. Okay, a function, we need to solve it first. We need to solve as y equals mx plus b so we can get the y-intercept, where m is the slope and b is the y-intercept. So right now I'm going to distribute 2 times x and then 2 times 3. So that will give me y plus 1 is equal to 2 times x, 2x, and 2 times 3, 6 positive. All right, to leave it as y only, isolate the y, I need to subtract 1 from the 6. So y, that's 0. Y is equal to 2x plus 5. So 5 is b is my y-intercept, which is actually 0 for x and 5 for y. And there's only one that has the 5. If there was more, then we would have to go to the slope, which is 2 over 1. You can see here that you have a good point there and a good point there, and you rise 2, and you rise 1, and you rise 2, and you rise 1. So that's the slope is 2, and the y-intercept is 5. So the choice is A. Pause your video as I quickly try to clear all my drawings, choose the right answer. There's no other 5 y-intercept, and go to the next question. All right. Okay, so the key about this one is to read. You can read it yourself, but he's feeding a dog 2 cups of dog food each day. The question, though, asks for a function that represents the amount of the food in the bag, left in the bag after X days. So because it's 2 cups each day, when you start is 0, you have whatever amount we have for Y. But then on day 1, the bag will have minus 2 cups from whatever amount it was. On day 2, you take another 2 cups and it's going to be a minus 4, and 3 is going to be minus 6. The difference here is, of course, linear. We're subtracting or adding a negative 2. And so I have a linear function, and the bag is decreasing as the food is being taken out of the bag. So it's food in the bag, decreasing or negative. So negative linear is the correct answer. Pause your video as I clear all my drawings. Choose negative linear because it's going down by 2 every time as x increases by 1. So it's negative because the bag is decreasing the amount of cups of food. Going to the next question. I am looking for a quadratic function. Okay, so very quickly, let me scan this. I see that this is times 3, and that would be an exponential function, exponent 3. Sorry, yeah, times 3, exponent 3. That's exponential, not quadratic. Quadratic is x to the second power. This is going like the bag. This is going linear, like the bag of food, linear negative. So this is exponential. This is linear. This is 7, no matter what x is. So that's a horizontal line at y7. So if y is 7, 6, 8, that's y. That's a horizontal line. This is x axis. That's not a quadratic. So the only quadratic formula could be this. Another thing, you look in a quadratic formula, you know that in a quadratic function, I should say, you know, you have a parabola. And when the parabola somehow passes through the y-axis, right? It cuts the y-axis. So you have a 0 there. So you're going to have a positive number giving you the same height because this height right here is reflected here on the negative side. So let's say that was a negative whatever number, -2 and -2. The same thing will be true for -1. It's going to be the same height. This height right there is the same height right there, both for -1 and for +1. Because 1 squared is the same as -1 squared. It's a +1. And 2 squared is 4. Obviously, I didn't draw this with the right function in mind because this is not a 0, 0. It's a 0, 5. The point being, though, that you have a -1 here giving you a +6. So a -1 that gives you a positive number, and a positive line that gives you a positive, the same positive height, the same +6. And that's a quadratic equation. It is a function because y can have the same target being used by a negative or a positive, but what you cannot have is you cannot have a line that curves back in, and so now you have the vertical test doesn't pass it because now you have the positive one giving you 2 values. You cannot have that as a function, but all that aside, it's okay to have the same height for both the positive and the negative, or even here, they don't have to be positive and negative. You can have another parabola right here, and for whatever these two numbers for x, there's a number x right here that gives you this height. There's a number x right here that gives you the same height. And so you have the same number for y for different values of x. So that's what you're looking for in there. Worst case scenario, you start graphing the points and see what changes quadratic. Quadratic is going to be a parabola. So quadratic will have a 2 exponent somewhere, at least on the x, maybe it's x minus 1 to the second power, and the shape is a parabola. Sometimes it goes up, like in this case, sometimes it goes down. Okay, pause your video. C was my right answer. Continue. Okay, the greatest slopes, let me just write them. So I have -1. Then I have 3/4, which is less than +1. Then I'm in between 3/2 and 5/3. If you're not sure, you can divide. Use your calculator. Let me see if I can do that. Okay, so let me divide 5 divided by 3. Is 1.6 repeated. And then the other number is 3/2. So 3 divided by 2. See how it compares to 1.6. So 3 divided by 2 is 1.5. So the greater one is 5/3, A. So we have then 1.5, which is 3/2. And then 5/3, which is 1.6 repeated. So the greatest slope is 5/3, or A. Pause. All right, a system of inequalities. X is less than 3 because the less than doesn't have the equal sign below, like that. It doesn't have it, so I'm going to erase it. That means it's a dotted line on X3. So we all the graphs have a dotted line on X3, that's no problem. Then Y is greater than or equal to -3. So I need a horizontal line that is solid. Because of this, the line has to be solid at -3. And all the graphs have it at all the graphs have it at -3. And the dotted line at +3 for X, vertical line. Okay, so now which way do I shade? If I have X is less than 3, I have to shade the numbers that are less than 3, such as 2, 1, 0, -1, and so on. So I would ideally shade all the way. But then Y is greater than -3. So all the numbers that are greater than -3 are going to be up here. So to solve the system is the intersection. This one, the brown arrow will go down, so this cannot be. All right. Now, this one again, sorry, let me repeat that. Let me repeat that on the right graph. So this one, we would have the y values being less than -3. So going this way instead of up from the line down is not what we have. It has to be from the line up because it's greater. So this is not the answer. This cannot be the answer for that reason alone. Okay, so what about the dotted line? The dotted line says less than 3. So I cannot go beyond 3 for x. And if I look here, if I go here this way, I cannot go in the other direction too. So this area is incorrect. That's not less than 3. You can see it's 4. So the only one that has the intersection of the blue and the brown arrows, both blue and brown, is A. And that's how you determine. I know you have a blue line here, but you don't have brown. And I know you have a brown here, but you don't have blue. So it's only this area right here. The dotted line. So it's A. Okay, pause your video. I'm going to erase and click choose A. That's my answer, is where both shades meet. Not just one, but both shades have to be part of it, the solution. All right. This one is going to be easy because we're going to understand what it says. It says that a ball was dropped from a balcony at a height of 20 feet. So there was a height. It was 20 feet. And there was a ball at 20 feet. All right. So above ground. So above ground. So there's the ground, and the ground, of course, is 0. 0 for the ground. Okay. The height in feet of the ball after t seconds. So t is time. Is measured by the function y. That means that y is the height, because the height is modeled by the function. So y is the height. So y is the height, which is whatever time it takes. Notice that it's a negative, meaning it's dropping. It doesn't mean we go before time. We cannot go backwards in time, but it means the direction is dropping. And so plus 20, which is the height. So the range is the values of y. So range is the y values for the function. We can see from the choices that all values begin at 0, because yes, at the beginning when we're graphing the height of 20, at that time before the ball is dropped, the time x is 0. So of course we have to start at 0, right? Now which one? The range is all the values. So what are the y values here? They go from 0 to 20. That is the height. This is y, the height. So this doesn't make sense because it doesn't take 20 into account. Neither does that. This is the time, not the height. And so it has to be D. The height goes, it begins at 20 where they drop it, and when it finally hits the ground sometime later, this is a, let's see, it's a quadratic equation. So it's accelerating. So it's going to eventually drop to, after some time, It's going to eventually reach the ground, and when it reaches the ground, the height will be 0. Whatever x is, the height is 0. And when x was 0, the height was 20. So this is the point 0, 20. Okay, so only D makes sense because it's not T. So pause your video. All right, exponential growth. Okay. Exponential growth. We see here that all the equations have an exponent, x, and those are exponential functions. So there's gotta be 3 that are decay and 1 that is growth, according to the equation. So the way we do that, we also notice that they all have a 2. So that's what they have in common. So what's different is what's inside the parentheses. We have a fifth, we have 5.0, we have 1 minus a fifth, which is 0.8, and we have 1 minus a half, which is a half, which is half. So the only one that's greater than 1 is 5. So that is exponential growth, because the other ones being less than 1, they're a fraction. And when we raise a fraction to a power, the fraction becomes smaller, not bigger. For instance, if I had a half to the power of 2, that would mean 1/2 times 1/2. What that will give me is 1/4. So the fractions that are less than 1 become even smaller when raised to a power x. So 5, however, will become 5 to the second power will become, for instance, 25. Never mind to the third power, that's 125, and so on. So the only one that models exponential growth is when the number in the parentheses is greater than 1. Greater than 1, or perhaps even 1. The point is, you cannot be less than 1. If it's less than 1, it's decay. So let me write that. Less than 1 inside parentheses is decay, not growth. Okay, pause your video. We're gonna do one more for 20. This is good for one video, but we cover a lot of ground in one time. At once, I should say. B is the answer. Continue. Okay, decay. Again, when the number is, the parenthesis is less than 1. Okay, so would it be 1/5 x or 1/5 to the power of x? It's exponential. This is linear. This is not decay because it's 5, like the previous example. This is linear also. This is negative linear. This is positive linear. This is what is it? 5x positive linear. So they're both positive, no decay. This is exponential, but it's growth. The parenthesis raised to a power of x is less than 1. And such parenthesis is raised to the power of x, so that's exponential. Exponential decay, to be exact, the answer is D. And with that, you can pause the video for good, because I'm going to stop the recording after I erase, clear all the drawings. See you on the next video.